Okay.
All right, so it says graph triangle LMN with vertices 2, 0, 2, 3, and 6, 0. So I'm going to do that in red here.
Okay.
2, 0, 2, 3, and 6, 0. You can see it's a triangle.
Mm-hmm.
It's good to label it L, M, and N. That's always a good thing.
Okay.
And then the next thing here is to graph the transformation. So I'm going to do that in blue. The transformation is well, you're going to subtract 3 from every x value, so it ends up being left 3. And
Okay.
then the y value is you're subtracting 4, so that's down 4. So one of the things you might consider doing here is actually making a table
Okay.
of the new and the old, and I'll also label it with the letters. So we've got L, M, and N, 2, 0, 2, 3, 6, 0. And then for the, you can think of it as the original, the new, if you want, we're going to go left 3 on each of them. So we're going to subtract 3 from each of the x values, -1, -1, and 3. And then for the next ordered pairs, we're subtracting 4 from the y values, -4, -1, -4. I feel like it's better to do it all together rather than to like try and do them at the same time, the transformations. And then you're just going to graph it here, -1, -4, -1, -1,
Where
and
did
then
you get
3.
the minus? I get the -4 from y -4, but where did you get the -1 from?
You're subtracting 3 from the 2. All of the x values get
Okay,
subtracted
so
by
we're
3.
doing the answer, not okay, okay.
Yes,
I got
yes. And then you do that for all of them. So 2 minus 3 is -1, 2 minus 3 is -1, 6 minus 3 is 3. Same thing with the y values, subtracting 4 from each of them.
okay.
That gives you new ordered pairs. And then the final thing is you're supposed to label them with a tick, little apostrophe, if you will. L
Okay.
tick, M tick, N tick, like that.
Okay.
Now, is it a rigid transformation? I actually need to look that up because I have no idea what that's referring to. Let's take a look here um, from the internet. Rotating it. Okay, so if it preserves the size and the shape, yes. So there are 3 types of rigid transformations. Let me actually, this is all from the internet here.
Mm-hmm.
So it simply moves a shape. It's called a translation, but it's also a rigid transformation. So uh, moving a shape is like right or left or up or down.
Uh-huh.
So that's rigid. A reflection, which we don't have here, is also rigid, and then rotation is a rigid transformation. So a non-rigid, you might be asking, what would a non-rigid be? It would be a dilation. Dilations are a scale factor, which I guess we'll see here in a moment when you got a
So,
problem.
so translation and reflection are rigid,
Yes, and
rotation is not.
the rotation is, sorry,
Oh, it is. Okay.
these are all rigid transformations.
Okay.
All right, so let's look at 2A. All right, so it says here, transform point A, where A 4, 2, using the coordinate notation. So it says here, it's negative x right here. It means to negate the x value. So you actually perform that operation on the x value.
Mm-hmm.
Y -4 means to subtract 4 from the y value. So 2 minus 4 is -2. Okay. And so the transformations they're looking for a list here. Okay, so the y is the easier one. It's down 4.
Mm-hmm.
Okay, but what is the minus x? So you almost have to make a graph of, okay, what does it mean? Okay, 4, 2 is here-ish, right there. So
Yeah.
-4 means over there. So which
Right.
axis does it reflect over?
It reflects over the vertical, the like the y-axis.
Y-axis or the vertical axis? Yeah.
Okay.
Okay. And so sometimes you got to draw it to see it if you're not sure. All right. And I know that it's also down here, but for just emphasizing what the minus x does, like if you're ever unsure, like what does one thing do, you just move the one thing.
Okay.
All right.
I got that. Yeah.
Let's go to more of the same here. All right, so we might need a reference sheet coming up here. All right, point B1, 4. So I'm going to draw that in red here. So 1, 4 is right there. And then the line x equals 2, I'm going to draw in blue.
Okay.
That's that line right there. And so
Okay.
when you reflect, it's like when you look at yourself in the mirror, you see the same thing on the other side. And if you could measure it inside the mirror, it would be the same distance apart. So this new point, it's kind of hard to show because it's so close, but it's 1 unit away, so it becomes 1 unit away there.
So then it would
Uh,
be 3, 4, like
Yes,
3, 4. Okay.
very good.
All right.
All right, so for the next one, I'm going to send you a reference sheet, or I'm going to actually also, maybe you've already got it. There's a real good one here. Let me see if this is it. This is it. Okay, so I'm going to drop this in the chat here. It's just a link to a reference sheet. There's a bunch of different types of rotations that you'll need to know. They're at the bottom here. I'm going to snip them in for this problem. Do you get a reference sheet or a note card for this exam?
No, but it says when I clicked on the link, it says blocked plugin.
Okay. Well, I can I would recommend maybe unblocking something. It's just a PDF. It's nothing unusual there, but I'll snip in as we need things here. So the rules
Um,
here, you can see that in the rules down here, there's counterclockwise. So just as a reminder, we don't look at analog clocks very often, but the clocks, that's clockwise. That's what we're expecting. Counterclockwise is going the other direction. Okay, counterclockwise. So in this problem, it's 90 degrees clockwise, 90 degrees clockwise. So that's this one here. And so you have to have the rule. You have to say, okay, it's XY goes to, it's that last one there on the right, Y minus X. So what this means is, and we're now rotating this new point 3, 4. The X value goes over to the Y value, but it gets negated. So it becomes -3. 3 for
okay.
the X becomes -3. The Y was 4, and now it becomes the X.
Okay.
Okay. So without these formulas, it's very difficult. Now, what I recall from your classes that they generally give these to you, but
Yeah.
yeah, it's worth at least having some idea of what they are before you head into the classroom there. Okay,
Yeah.
here's another one for us to do. Part C. And I'm going to snip in a new graph again, just because it'll make it easier to explain if we need to. Sometimes I think graphing it's really important. I think I'm very visual. I think visual stuff really helps when you're learning. So here's
Yeah.
the point. 2 minus 1 is right there. That's C. And it's
Okay.
reflected over this line. Y equals X.
Okay.
Okay. Now perhaps you could sort of visualize where that is, but there is a rule for this. These are the other rules on that sheet of paper that I sent you, or that link I sent you.
Mm-hmm.
So over the line y equals x, xy goes to y comma x.
Mm-hmm.
Basically, x and y flip-flop. So your new ordered pair is -1 comma 2. And when you graph that point, what you're supposed to see, and I'm not drawing it very well, but you're supposed to see that it's basically equidistant to that line there. Kind of see it flipping over that
Yeah.
line.
So because like with the other one, it was like y equals blank or x equals blank. Because it's like they're equal to each other, it kind of just like, I'm a little confused on that part.
They're just rules. They're just, you talking about the y equals x line?
Yeah.
That's just a line. And that line goes through, it basically says that x and y are the same everywhere. So when x is 0, y is 0. When x is 1, y is 1. When x is 2,
Oh,
y is
okay.
2. That's all
Okay.
that is. And that's like, it's like a mirror. It's like a diagonal mirror that we're not used to seeing. But
Okay.
those the old point and the new point, they just flip over it. It mirrors over it.
Okay.
All right.
Then I got that.
So having these rules, super important, not really much way to do it other than that. And so,
Mm-hmm.
we get to problem 3 here, and we're finally up to dilations. So that's the better word for this is scale factor.
Okay.
Excuse me. And it even says okay, scale factor. So you use the scale factor, whatever that scale factor is, and you multiply both x and y by scale factor. So let me write the original point here, -1 comma 3. You multiply both -1 and 3 by 3. So this becomes -3 and 9. You're multiplying by 3, multiplying by 3. Could you
And we're
tell
doing
me
that to
what,
both A and B?
yes, could you tell me what B prime would be?
Yes. B prime, and that prime is just the like the little
It's to denote that it's
thing with
different
it,
than the old
right?
one. Yes, it's just
Okay. So it'd be B prime is 9, -6.
okay, good. All right, now we're gonna graph the line from A to B. So from A to B is -1, 3 to 3, -2. And we're just gonna connect that line. Something like that. That's not very good. Let's do a little better job. So what the dilation will do, it will increase the length of this line by 3. Okay, it doesn't, but it
Mm-hmm.
changes where it is as well. That's where I think there's a little bit of a disconnect about what it actually does. -3, 9 is up here. 9, -6 is here. If I do a really nice job of drawing it, I think you could see that it's about 3 times as long.
Yeah, appears to be.
Yes. And that's really, that's the whole point. That scale factor tells you the new length of the line.
Right. And we already know that the scale is changing by 3.
That's right.
Okay. Yeah, that makes sense.
Let me get going here on the next page. I appreciate you sending stuff over in advance. It's always nice. All right. Yeah, so good. Some problems where I can get you to have some involvement. This will be good. All right. So problem 4 here. New problem here. Before you even worry about or start doing any of the rotation or shift, any of this stuff, you should just
Mm-hmm.
label the points. You should say, okay, I got B, S, and L. And can you give me the ordered pairs of B, S, and L, please?
Yes. Okay. So B is, well, if we're going based off of like each
Assume it's
one,
one. Yeah, assume it's one.
okay, then it would be So it'd be B would be 4 and then 5.
Okay, good,
And then S would be 2, 2.
good.
And then L would be 5, 0.
Okay, very good. So now, here is the rule. This is the rule here. I'm gonna snip this in. And then I'll just move it up here. So the rule for 180 degrees, doesn't matter whether it's counterclockwise or clockwise, it's the same thing. We can talk about why, but you have to figure out your new points, B prime, S prime, and L prime. And you
Mm-hmm.
do that with this rule. The rule is very clear. It says take X and Y and just negate them.
Mm-hmm.
Just whatever they are. If they're positive, they become negative. If they're negative, they become positive. Now here they're all positive, so your answers become all negative, but
Right.
it just, that negative means to change the signs.
Okay.
Sorry
So
about that. So could you
yeah,
go ahead and write those down for us?
yeah. Okay. So it would be, and I mean, it's just gonna be, since it doesn't say whether it'd be clockwise. Or wait, it's 180, so it doesn't change. Okay, so now it would be B is -4, -5.
Good.
S is -2, -2. And L is -5, 0.
Okay. And I really like graphing them in a different color. It's obviously, easier for me because I got digital ink here on the computer screen. But if you like
Yeah,
colored pencils or pens, I mean, I would recommend that. Plus, it just stands out. There's no like confusion about which is the old and the new.
yeah.
-4, -5 is down there. Always good to label those points. -2, 2, and then -5, 0.
Okay.
And it should look the same. I mean, to the best of your ability to graph it. And I've of course graphed this wrong. So it's the point is actually there or to the right.
Mm,
It's
yeah, mine looks like that.
any questions on that?
No, I think I got it actually.
Awesome. Yeah, so the next few are going to be very similar to this. We're going to be uh let's say like basically making a table and then doing the same thing. So for B, what I want you to do here is I'm going to snip it in and I'm going to snip in the rule. So this is a 90-degree rotation clockwise about the origin. Okay, so this is the rule for that. Let me see if I can get it snipped in. This is the rule. So it's the same values, but you just have to arrange them. So I'd like you to create the table of values and then graph the new ones and see if you kind of see the 90-degree clockwise rotation.
Okay. So it says about the origin. Wait, so
That
because
that
the
that
origin,
doesn't matter. Yeah,
so
it's always going to say that. It will always be referring to that when you're doing a rotation.
so it
You
is
don't
basically the old, the answer, I guess the second triangle we did from the first part is what we're going off of.
That's a good question. I think it's the original because they're giving you
You
the
think-
original there. So I think you just go back to the original. It's good question though.
Okay,
So
so
the BSNL that we did from the previous problem there.
so rotating 90 degrees clockwise would be change, okay, y and then negative. So let me like do this really fast. Two, um, and then y doesn't change. Mm, Okay, so I guess in this case, B prime is 5, -4. S prime is 2, -2. And L prime is 0, -5.
So what you have to kind of decide is does this thing look like a 90-degree clockwise rotation? And it
Mm,
does. And kind of the if you want to kind of know what would it look like, it's imagine a piece of paper kind of rotating on one of its, like if you put a pin on it somewhere and it just rotated, you know, it would look kind of like
yeah,
that. So does it kind of have that look? You can usually tell whether it's right or wrong. You should go by the formulas, of course, but um, just something to think about.
okay.
Any questions on that?
I actually think I have it.
Cool.
I got that part.
All right. So number 5 is a little weird, of course. You always get kind of one of these problems that just seems a little bit out of scope, but um, yeah, maybe you're more of a visual person as well, where kind of you can see things. They don't have to be right in front of you to
Yeah,
things like that. So
yeah,
we need to graph the parent function, absolute value of x, y, and y is the absolute value of x. So let's go -2, -1, 0, 1, and 2 for x. Do you remember what the absolute value function does for the values of x?
no. Or does it
So
just
what?
like, yeah, I actually don't know. I forgot.
So the absolute value, what it does is it always returns the same value. And if it's negative, it becomes positive. But if it's positive, it stays the same. So this is the one that looks like a V.
Right.
You would have seen that last year.
Yeah.
Not in geometry. They tend to not emphasize functions, but it looks like that. Okay. Something
Okay.
like that. It's the V graph. Now the
Right.
line y equals x is this line right here.
Okay.
Okay, so the question is, well, what does the graph uh what does the graph look like when you reflect it? So that's this arrow going up and to the left here. I think you can see pretty clearly that if it were reflected, it would just come down like that.
Right.
Maybe show that in a different, show that highlighted so you can see that. But what about the
Mm,
part that's going up and to the right?
mm,
It's like on the line of reflection.
right.
So what happens to it? So it just stays the same.
Okay.
There's not, when it's on the, like, it'd be like if I said reflect something over the x-axis and it's already
Mm,
on the x-axis, it just stays there.
right. Okay.
Does that make sense?
Yeah, I think so.
Okay. All right. Well, let's move on to next page here.
Okay.
Get your graph. So this is problem 3.
Okay. I believe.
Problem 3. Guess they're not ordered, or this is a different thing. That's okay. All right. Okay, sketch a graph of the unit circle. X squared plus y squared equals 1. Do you have any idea, remembrance of what the unit circle looks like?
Uh, isn't
It's
it
okay if you
just,
go.
isn't it, isn't it just, I'm forgetting if it's by 2 or by 1, but I'm pretty sure it's just 1 0 0 1 -1, 0, and 0, -1.
Exactly. Makes you wonder why you're given so much room on this graph.
Yeah, really.
4 points, but label 4 points. You did that perfectly. 1, 0, 0, 1, -1, 0, 0,
Yeah.
-1, like that.
All right. Oh, wait, that's it? That's all I'm doing?
Yes.
All right.
There's nothing more to do.
Then why is it so, this graph is ridiculous.
Yeah, the next two parts are a little out of scope for your class. You'll do this more in trigonometry for sure, but especially the next one, actually. This one's kind of okay. So we're going to take those 4 points that you just came up with. 1, 0, 0, 1, -1, 0, 0, -1. And we're going to do these transformations here. So when you see the transformations in this form, you just perform the operation as is. Like you're going to add 2 to the X values. You're going to subtract 3 from the Y values.
Okay, so here, I think I got it. Just give me a sec to do
Sure.
math. Okay, so I got them. I just need to graph it, but I'm pretty sure it would be 3, -3, 2, -2, 1, -3, and 2, -4.
So go ahead and graph this for us, please. And let me know what you see. It should look pretty similar to
Yeah, it's just the same thing, just moved differently. It's a, what was it called? A rigid,
exactly.
yeah.
Wow, you should be the one teaching. You're using the right language and all that.
I'm just confused how to do the equation. I can't hear you. I don't know if you're talking or not, but I can't hear
Oh, I
you.
was just waiting to see if you graphed it. Okay, so for the
Oh, yeah.
equation, this is where it gets a little this where it gets a little weird because you may or may not know this. The equation of the circle is x minus h squared plus y minus k squared equals r squared. And h and k represent the center of the circle. Now you can see right here, the center is where I've made this red dot. What's the ordered pair of the center right now?
Ordered pair of the center is 2, -3.
Exactly. So that's your h and k value. So the way this works is you put the value in exactly the way it's written. So in the case of a negative, it's y minus -3 squared equals r squared. In your problem, the radius is 1.
Okay.
So that's
So
x
the original setup, I guess, for an equation for a circle is always going to be um, x minus h squared plus y minus k squared equals r.
squared. Yes.
Okay. So then,
And,
yeah,
and,
it would be.
and that does work for the original one that we graphed. So if if we need to, we can give more of a conclusion on that.
Okay. So it would be y plus 5.
No, just y plus 3.
Okay, that's what I
Squared.
got. I didn't
Yeah.
know if that was a 5 or a 3. Sorry. Wait, 3, 1. Okay.
All right, now the the next one, this is the one that's really, really awkward. Can't believe you guys have to do this because it's actually not a circle anymore when we're all done. It says the unit circle from part A has a vertical stretch of 4. So it's those same 4 values that we just did here, these first 4, because it says from part
Mhm.
A,
Right.
but you're now stretching vertical stretch of 4. So a vertical stretch of 4 only affects the y value. The y values, they get multiplied by 4. X
Yeah.
values stay the same. So I'd like you
Only the y
to
value.
create the new ordered pairs and then graph. And I think you'll see that it looks very odd. It will
Okay.
not look like a circle.
I mean, I think I have done this before, and when I did this part, I mean, I don't think that this is like the mathematically like correct way to do it, but I just like replotted the circle, like the one we did for A, and then just moved over 4. But I feel like technically that doesn't work.
No, you're multiplying. You're multiplying the y values by 4.
Multiplying y value by 4. Okay.
That's what a stretch does. It always multiplies.
Okay, multiplying by 4. Hold on. And just the y value?
Just the y values.
Okay. And then what is it? Okay, so then it would be 1 0
Okay, agreed.
0 4
Okay.
-1 0 and 0 -4. And then it just looks like it was vertically stretched.
So go ahead and graph that as well.
Yeah, I graphed it.
Okay, so the graph, this new graph, looks something like this. Which you're about to see. Does that look like a circle to you?
No.
No. Okay. So it's actually something totally different than a circle. I'm going to give you the equation because I don't know that it would ever be possible to figure this out without a lot of trial and error.
Okay.
So that is the new equation. I don't know why it's asking you for that, but it's not. I'm sorry, it does not ask you for the equation. Just asks you for the transformation. X stays the same, but Y goes to 4y.
So I would just write it as x and then y times 4.
Yes.
Okay. So I just put it still in parentheses as x and then y times 4. Perfect. It's all written out.
All right, so if you got that down, what should we do next? We got some,
Is there any problems that are kind of like this? Because that's all I have access to.
I can
Like,
certainly
do
make some
you
up
have
here. I mean,
any?
I'm not sure we've got 10 minutes worth of questions if you've got all this down, but let me do this first. Let me have you get down or make sure you've got the rules for the reflections
Okay,
down. So these rules you need, and then the next set of rules you will need as well. And I guess I can give you some problems like this
okay,
to think about. You really got to have these down.
okay,
Let me go find. Actually, I do have something I worked with another student on. I can go find. It
okay.
was a rotation practice. But some of these are, yeah, actually we'll do this. Here's some good ones. All right, so not sure if we'll need those rules, but I'll throw some problems up in front of you. Um,
Okay.
this one asks you to write the rule to go from the triangle in solid black to the one in the dashed lines.
Okay. Um, so wait, how, like, you're asking how I get to that?
Yes, you have to come up with a rule. You have to say, so a rule, for example, would be, let me go give you an example here, like this is a rule here. Your original problems gave you a rule. Sorry, like this is a rule up here.
Rule is, oh, okay, I see.
Yes.
So the rule for that would be, mm, um, I think I might have, I'm supposed to be able to figure it out. Basically, I'm supposed to like write it out, right? And like see
So
what the
one thing,
difference between the two are.
yeah, I mean, one thing you could do is write out for each point. You could say, for example, like what happens as B goes to B prime by writing out the ordered pair for B and then for B prime, and then
Right.
deciding, like what's going on.
Okay. I'll do that. Mm, hold on, I just need to be able to like zoom in, I think, on the, okay, there we go. So it's going by 2, so it would actually be, I should do it to the other ones too, right? Because that's how I like sense a pattern.
If you need to, like sometimes you can say, oh yeah, I get it after one point. If not, do a second.
Okay. Okay, wait, is it just saying that, well, actually, wait, no, let me do one more part and then I'll probably have it myself. Um, mm, is it just X as being like +2?
So I'm looking for something like this, and this isn't right, but it would be like X goes to X minus 5. Y goes to, 3Y, for example, but these are not right. These are not correct. That's kind of the rule that I'm looking for. So is that what you have written down or something like that?
Not really, no.
Okay, so B is 4 comma 10. And then
Okay.
the new B, which I guess is a little bit hard to tell. I mean, 'cause it's not going by ones, but it's 6 comma 6. Okay. So how do you go from 4 to 6?
Um, how do you go from 4 to 6?
You add, subtract, multiply, divide, and by how much?
Oh, to go from 2 to, sorry, to go from what to what?
4 to 6
Oh, +2.
plus 2. Okay.
Right,
So
that's what
then,
I have. I just have it as
okay.
X +2.
Right. So X goes to X plus 2.
X plus,
And
oh
then,
yeah, it's X is plus, or yeah, X is X +2, Y is Y minus 4.
okay. Yes. And that's what I was looking for. That's exactly right. Okay. Very good.
Yeah.
So, let me see if I can find another one like that. All right, so I don't have one exactly like that. Uh, kind of, I guess, kind of. So let me snip this one in. All right, so same thing here. Could you determine the rule for these two ordered pairs?
Yes. Let me do that. Mm, Okay. So X is now X minus 2 and Y is Y plus 2.
Okay, now I just ask here because I want to make sure I understand. Did you go from the black one to the dash black one?
Yeah.
Okay, so we're going from minus, for example, from -7 to -5. When you're going to the right, you're adding 2.
But
So it'd be
doesn't when you go like negative, oh wait, oh no, I guess you're right, because if you were to do it, it'd be like keep change, and then it would be -7 and
yes.
-5, and that doesn't work because that would be like negative 12.
All right, very good. Okay, I think we
Okay.
got time for kind of one more. These are intentionally kind of vague the way I'm doing it because They're kind of stop and think problems. For this one,
Yeah.
I would recommend possibly a quick sketch. Doesn't have to be very accurate, but it just needs to sort of like help guide you with like, is it a, you know, is it a flip? Is it is it a stretch? Is it a, you know, what
Okay.
is it?
Um. Okay. A triangle has vertices. So I need to. Yeah. I just need to sketch it down. And I think also what I can do to make it easier, I have some graph paper. Hang on. Okay. What would be?
Well, yeah, we're gonna run out of time. I didn't realize what time it was. So let me kinda, so it's 1, 3 goes to 3, -1. And when you look at that, you're like, ah, it doesn't really look like much. Like maybe it's +2 and -4, but then you get the next point here, 4, 2, and that goes to 2 -4. And you're like, well, +2 doesn't work anymore because 1 + 2 is 3, but 4 + 2 is 6, so that's out. But notice that
Right.
it's kind of got the same numbers in there. X
Uh-huh.
and Y are sort of there. And that's where you got to kind of say, okay, it's really Y -X. So if you see the
Okay.
same numbers over and over again, you can do it that way.
Okay.
But unfortunately, we are out of time.